Hello students, let's see the method of preparation, properties and uses of chlorine. So chlorine, that is Cl2, let's see the method of preparation first. First one is when MnO2, manganese dioxide, is treated with HCl, it produces MnCl2, H2O and Cl2. So chlorine is produced in this case. So manganese dioxide is actually heated with concentrated HCl. We will get these products and chlorine will be the main product. So instead of HCl, we can use NaCl and H2SO4. So NaCl and H2SO4 will produce HCl. So we can add MnO2 here. Here also we will get the same products MnCl2, H2O plus chlorine, and one more byproduct NaHSO4. So NaHSO4 is actually formed from NaCl and H2SO4. So when NaCl and H2SO4 reacts together, it produces HCl and NaHSO4. So HCl is used here and that reacts with MnO2, produces these products, and NaHSO4 will be getting as the byproduct. So this is the second reaction. Third reaction is another manganese compound, that is KMnO4, potassium permanganate. Here also we will use HCl. In this case we will get KCl, MnCl2, H2O and Cl2. So in all these cases we will get Cl2. So the manganese compound react with Cl minus. So in all these cases Cl minus will be there. So it produces Cl2. So that is the reaction. Now let's see large scale preparation method. Large scale preparation of chlorine. Here the first method is called a Deakin's process or Deakin's method. So in this case HCl on oxidation with atmospheric oxygen in presence of CuCl2. So this is important. CuCl2 is used as a catalyst here. So the reaction is HCl plus O2 gives H2O plus Cl2. So the catalyst is CuCl2. So that is an expected question, that is which is a catalyst used in this Deakin's method. So this is another method, so which is a large scale preparation method. So all these equations are to be balanced. Now another method is electrolysis of aqueous brine or brine solution. Electrolysis of brine solution. Actually brine solution is aqueous NaCl. Sodium chloride solution is called a brine solution. So electrolysis of brine solution. So that process produces chlorine is produced at the anode. So that is the reaction. So when electrolysis of brine solution takes place, chlorine is produced at the anode. So actually aqueous NaCl means Na plus, Cl minus, H plus and OH minus. So these ions are present in brine solution. So Na plus, Cl minus, H plus and OH minus. Since it is aqueous NaCl, all these ions are present here in brine solution, and we know Cl minus, that is a negative ion, that will move towards anode. So that will move towards anode. So at the anode oxidation takes place. Anode is for oxidation. So in that electrode or in anode, oxidation takes place and Cl minus changes to Cl atom, and two Cl atom combine together to form Cl2 gas or Cl2 molecule. So anyway, chlorine will be liberated at the anode. So electrolysis of brine solution produces chlorine, which is produced actually at the anode. That is a reaction. So these are the method of preparation of chlorine. Now let us see the properties. First of all, let's see the physical properties. So in the case of physical properties, we can see, I have written here, it is a greenish yellow gas. The color of chlorine, that is greenish yellow. And about its smell, it is pungent and suffocating smell. So it's a pungent smelling gas, or it is having suffocating smell. Then about its solubility, it is soluble in water. It is highly soluble in water. So these are the physical properties of chlorine. So I have written here greenish yellow gas, pungent and suffocating smell, soluble in soluble in water. Then let's see another properties, that is actually chemical properties. So first of all, it reacts with metals and non-metals, to produce the corresponding chlorides. So when chlorine reacts with metals or non-metals, produce corresponding chlorides. Let's see some examples. Aluminium, iron, sodium. So these are some examples of metals. Then comes P4 and S. So some non-metals. So in this case, we can add chlorine here. In all these cases, corresponding chloride will be formed. So these are simple reactions, AlCl3, then FeCl3, NaCl sodium chloride, PCl3, S2Cl2. So these are the chlorides formed in this case. So you need to balance all these equations. So this is about with metals or non-metals. So chlorine reacts with metals or non-metals, produce the corresponding chlorides. Now let's see another reaction, that is with hydrogen. So actually chlorine is having greater affinity towards hydrogen. So it reacts with hydrogen. So with hydrogen, and also it reacts with the compounds containing hydrogen. Compounds containing hydrogen produce HCl. So HCl is the main product in this case. So first of all, chlorine reacts with hydrogen, produce HCl. Now let us write a compound containing hydrogen, H2S plus chlorine. It produces HCl and S. Then another compound containing hydrogen, that is C10H16 with chlorine. Here also we will get hydrochloric or hydrogen chloride plus carbon here. So in all these cases we can see HCl is produced. So it is having greater affinity with hydrogen and compounds containing hydrogen. So it produces HCl in all these cases. So these equations are also to be balanced. Now let's see another chemical property, that is with ammonia. So with ammonia, chlorine react with ammonia to produce some products. So in this case we need to check the amount of ammonia and chlorine are to be taken. So third point, that is with ammonia. So in the first case we need to take NH3 in excess and chlorine. In the second case, chlorine is taken in excess. So these are the two sets of reaction where ammonia reacts with the chlorine. So in the first case, we can see N2 plus NH4Cl. So these are the products. In the second case, HCl and NCl3 will be formed. So these are the two reactions with ammonia. So first case NH3 will be taken excess. So here we can say nitrogen. So since nitrogen or ammonia is in excess, two nitrogen compounds will be formed. Here chlorine is taken in excess, so two chlorine compounds will be formed. So in that way you can remember these two equations. Anyway, ammonia reacts with chlorine in two ways. One is ammonia in excess and the other one is chlorine in excess. So in this case NCl3, this can be used as an explosive. So that is nitrogen trichloride. So nitrogen trichloride is used as an explosive. So this is a reaction with ammonia. Now let's see the reaction with some alkalis. So how does chlorine react with alkalis? First of all, let's see with NaOH, sodium hydroxide. That is an example of an alkali. That is the fourth reaction with alkalis. First of all, we can take NaOH. In this case also, we need to check two reactions. One is chlorine with NaOH. Here it is called dilute NaOH. That is the first case. Second case, chlorine with NaOH. This is hot concentrated NaOH. So these two equations are very important. In this case, here we will get NaCl plus H2O. Here also NaCl plus H2O. And here NaClO3. Here NaClO. So these are the products. So NaCl and H2O, these are common products in this case, and NaClO, when cold and dilute NaOH is used, NaClO3, that is produced when hot and concentrated NaOH is used. So these two equations are very important with alkalis. That is, NaOH is an example of an alkali. So two sets of reactions can be seen here. One is with cold and dilute NaOH. Second one is with hot and concentrated NaOH. So here we can expect a question. Is this equation or is this reaction is this a disproportionation reaction? Disproportionation reaction. Justify. So is this a disproportionation reaction? So in this case we can see it is a disproportionation reaction. Actually it is a disproportionation reaction. So how can you justify? So in this case Cl2, that is in zero oxidation state. Here it is in -1 oxidation state, the Cl. And in this case it will be, since it is -2 and +1, -6 + 1, so it will be +5. So the same element chlorine, shows different oxidation state. That means three different oxidation states are seen here. So one is 0, the one is -1 and the other one is +5. So 0, -1 and +5. So these are the oxidation states shown by the same element chlorine. That means the element chlorine is oxidized and at the same time it is reduced. So it is actually a special type of redox reaction that is called a disproportionation reaction. So disproportionation reaction, in disproportionation reaction, the same element will show different oxidation state. So here in the reactant side, it shows 0 oxidation state. In the product side, it shows -1 and +5 oxidation state. So 0 will come in between -1 and +5. So the lower oxidation state is -1 and the higher oxidation state is +5. So in between 0 comes, and that 0 will be the oxidation state of chlorine in the reactant side. So that is about disproportionation reaction. So anyway, this reaction is actually a disproportionation reaction where we can see chlorine is having 0, -1 and +5 oxidation state. So the same element is oxidized and reduced simultaneously in this chemical reaction. So this is about with alkalis. Now let's see another alkali. We can see another alkali also, that is CaOH twice. CaOH twice is flaked lime. CaOH twice, that is flaked lime. So when chlorine is passed through CaOH twice, flaked lime, so it produces CaCl2 plus H2O plus CaOCl2. CaOCl2 twice. So these are the products. So here chlorine on passing through slaked lime, it produced these compounds. Actually this is bleaching powder formation. So this is bleaching powder formation. So bleaching powder is produced in this case. So when chlorine is passed through CaOH twice, bleaching powder is produced. So bleaching powder is actually the chemical composition of bleaching powder is CaCl2 dot CaOCl2 dot CaOH twice dot Cl2 CaOH twice dot 2H2O. So this is the actual composition of bleaching powder. So this can be written from this equation. So CaCl2, CaOCl2 twice, OCl2 twice, CaOH twice dot 2H2. So this is the actual composition of, or the composition of bleaching powder. So this is the actual composition of bleaching powder. So bleaching powder is produced when chlorine is passed through slaked lime. So this is the preparation method of bleaching powder, and this is a reaction with the chlorine with another alkali, slaked lime. Now let's see another reaction, that is with hydrocarbons. How does chlorine reacts with hydrocarbons? So with saturated hydrocarbons, with saturated hydrocarbons, it gives a substitution product. With unsaturated hydrocarbon, it produces an addition product. These reactions you have already studied in class 10. That is when chlorine reacts with saturated hydrocarbon. For example, CH4. This is a saturated hydrocarbon. It's an ANE, methane, alkane. So here we can expect a substitution product, CH3Cl. That is chloromethane. So this is chloromethane. So this is a substitution product. So if you are taking an unsaturated hydrocarbon, so chlorine reacts with an unsaturated hydrocarbon C2H4. C2H4 is CH2 double bond CH2. This is ethene. It's an ENE. So it is an unsaturated hydrocarbon. Here we can expect an addition product. So we can write the equation like this. This is 1,2-dichloroethane. So 1,2-dichloroethane. Or we can write CH2Cl, CH2Cl. So this is 1,2-dichloroethane. This is actually an addition product. So with saturated hydrocarbon, it gives a substitution product. With an unsaturated hydrocarbon, it gives an addition product. So these are the reactions. Now let's see the reaction with the water. So we have seen it is soluble in water. So let's see the reaction. Cl2 plus H2O. We can write like this, Cl plus HOH. Here HCl plus HOCl or HClO. HClO or HOCl. So this is hypochlorous acid. Hypochlorous acid and HCl. So hydrochloric acid. So chlorine reacts with water, or when chlorine is added with water, it produces HCl and HOCl or HClO. So this is an important reaction. Here we can expect a question, that is, when chlorine water on standing the yellow color fades. Why? So actually chlorine water, when chlorine dissolved in water, chlorine is having a greenish yellow color. So it is having an yellow color. So that yellow color fades away. So when chlorine water on standing, so the yellow color fades. Why this happens? This is due to the formation of HCl and HOCl. So due to the formation of HCl and HOCl or HClO. So this is the reason. So in this case, we can see hypochlorous acid is formed in this case, and this hypochlorous acid is actually unstable. HClO, this is unstable, and this produce HCl and nascent oxygen. So this is another important point. This is nascent oxygen. So this nascent oxygen produced by this HClO, that nascent oxygen is responsible for the bleaching property of chlorine. So bleaching action of chlorine is there. Chlorine is a bleaching agent. So the bleaching action of chlorine is due to the formation of nascent oxygen. So this nascent oxygen reacts with color plus this nascent oxygen produce colorless. So that is a reaction. Actually, when colored material reacts with this nascent oxygen, produces colorless material. So the bleaching action of chlorine is due to the formation of nascent oxygen. And also we can say the nascent oxygen formation is the reason for the oxidizing property of chlorine also. So we will see that oxidizing property. So here this HClO is actually formed from this equation, that is chlorine with water produces HCl and HClO, and HClO is actually unstable and that produces HCl and nascent oxygen. So this nascent oxygen is responsible for the bleaching action of this chlorine. So these are two important questions. One is when chlorine water on standing, the yellow color fades. Why? And another question is the reason for bleaching action. Reason for bleaching action of chlorine. So this nascent oxygen is responsible for bleaching action. This nascent oxygen is responsible for bleaching. So that is about the reaction with the water. Now let's see the oxidation property. So I have told you the nascent oxygen produced in this case, that will be the reason for the oxidation property of chlorine. So chlorine will act as a good oxidizing agent. Chlorine is a good oxidizing agent. Actually, it converts or it oxidizes. It oxidizes Fe2 plus to Fe3 plus sulfite to sulfate, then SO2 to SO3, then I2 to iodate, okay, these are the three reactions we need to check. That is, chlorine oxidizes Fe2 plus ferrous to ferric, Fe2 plus to Fe3 plus, sulfite to sulfate, SO2 to SO3, I2 to iodate. So these are the three oxidation reactions that we need to study for the oxidizing property of chlorine. So first of all, let's see with Fe2 plus. Here FeSO4 plus H2SO4 plus Cl2. Here Fe2SO4 thrice plus HCl. So this is the reaction. So you need to balance this equation. Here we need to check the oxidation state. Fe2 plus changes to Fe3 plus, since Cl2 act as an oxidizing agent. So Fe2 plus, here it is minus 2, it should be plus 2. So this plus 2 changes to, here it will be plus 3, minus 6 plus 6. So it is plus 3. So plus 2 changes to plus 3. So this is actually oxidation. So Fe2 plus changes to Fe3 plus. So here Cl2 will act as an oxidizing agent. That is the first reaction. In the second case, Na2SO3 plus H2O plus Cl2 gives So here Na2SO3. So Na2SO3, SO3 changes to SO4. So SO3. Sulfite. So I have already told you sulfite changes to sulfate. So that is the reaction. So that reaction takes place in presence of Cl2. So Cl2 here act as an oxidizing agent. Now the next reaction is SO2. SO2 changes to SO3. So here SO2 plus H2O plus Cl2. Here also Cl2 will act as an oxidizing agent. It produces SO3 plus HCl. So we are expecting SO3 plus HCl. Actually this SO3 reacts with H2O, produces H2SO4. So here SO3 changes to SO3. Actually SO2 changes to SO3, which reacts with H2O, produces H2SO4. So this will be the products. So SO2 changes to SO3. That is another reaction which shows the oxidizing property of chlorine. Then another reaction is I2. So iodine. I2 changes to iodate. Here also H2O plus Cl2. It will be HiO3. So iodate is IO3. In that case also, that reacts with water to produce this acid HiO3 and HCl. So that is iodic acid. This is called a iodic acid. So in short, I2 changes to iodate. That is the reaction. So I2 changes to iodate. So HiO3, IO3 minus, that is iodate actually, HiO3, here H plus and IO3 minus, IO3 minus is iodate. So this is iodic acid. So these are the products. So in all these cases we can see chlorine will act as an oxidizing agent. So chlorine will be acting as an oxidizing agent, where we can see Fe2 plus changes to Fe3 plus, sulfite changes to sulfate, SO2 changes to SO3, I2 changes to iodate. So these are the reactions supporting the oxidizing property of chlorine. Now let us see the uses. So you have to refer the NCERT textbook for the uses of chlorine. But one question is important from the part of uses that I will tell you, that is, so name the poisonous gas. Name the poisonous gases produced from chlorine. So that is an important question, can be expected from the uses of chlorine. So here one is tear gas, the other one is mustard gas, and the third one is phosgene. So these are the three poisonous gas produced from chlorine. So other uses you have to refer NCERT textbook. So this is about chlorine.